Hi everyone. In the previous class, we have seen the concept of counters, right? I mean, we have introduced the concept of counters and also the concept of frequency division. Frequency division, right? So if you look into the counters, so like basically it can be up counter or it can be down counter, or it can be a random counter, or it can be a combination of both up or down counters like that, right? Coming to frequency division, if I am going to give certain frequency to the respective counters, for example, if I say that it is a kind of mod n counter. Mod n counter means it is going to produce the values from the 0 to n minus 1. It is going to produce a frequency of frequency by n. So number of flip-flops is changing, that frequency is going to be reduced, right? Yes. Similarly, if I say that frequency is f and it is going to have behave as mod 6 counter, definitely its frequency is going to be f by 6. Or in some kind of competitive examination, they will give like this. If I am going to have two mod counters, one is mod n counter, another one is mod m counters, guys. Mod n counters, right? So can I able to get the frequency as like as the same above one? Like if I say this is a, as like as the same a, if I am going to combine both into a single kind of counter, mod nm counter, yes, of course you are going to get same frequency only, right? Yes, fine. So this is what we have seen in the previous class. Now in today's class, basically guys, these counters are classified into two types. One is asynchronous counters, another one is synchronous counters, right? As like as the flip-flops, the way they classified asynchronous flip-flops as well as synchronous flip-flops, they are again classified as asynchronous counters. Another one is synchronous counters. Generally, where they are going to produce the difference is the way you are going to apply the clock signal. Whereas coming to asynchronous flip-flops and synchronous flip-flops, in synchronous flip-flops you are going to apply the clock signal, meaning that at the same instant of time all are going to be responded. Whereas coming to asynchronous flip-flops, even if you are trying to apply the clock signal, if you are going to use preset or clock, these are going to have highest priority and it's going to produce the output asynchronously. That is the difference between asynchronous flip-flop as well as synchronous flip-flop. Coming to the synchronous counters and synchronous counters, in asynchronous counters, all flip-flops are going to be responded for the same clock signal. I can call it as synchronous counters. I mean, if all kind of flip-flops respond for the same clock signal, I can call it as synchronous counters. Whereas coming to asynchronous counters, if all the flip-flops, just opposite to this one, all the flip-flops are not going to respond to the clock signal, I can call it as asynchronous flip-flops, right? Or in other terminology, if I say the output of one clock signal drives to the clock of another flip-flop, I can call them as asynchronous counters. Both are important, guys. Important, right? So the meaning is, if I try to represent in the form of some simple format, asynchronous flip-flops means, general in our understandable terminology, we are going to apply different kind of clock signals. Different clock pulses will apply for different flip-flops. I can call it as asynchronous flip-flops. if I take into the synchronous counters, we are going to apply same clocks to all flip-flops. I can call it as synchronous counters. Synchronous counter, right? So if you want, I will give the example, right? So in the earlier class or in the earlier video, I have taken an example, right? So the example for how the counters are behaving. If you are going to understood here how this flip-flop is getting the input, how this flip-flop is getting the clock, this flip-flop getting the clock from the other flip-flop, meaning that this flip-flop 2 is dependent on flip-flop 1. So I can call this as asynchronous counter. Asynchronous counter. Asynchronous what kind of counter? Asynchronous what kind of counter? Asynchronous mod 4 counter. Asynchronous mod 4 counter. What about this one? Is it asynchronous mod 4 counter or not? This is also comes under asynchronous mod 4 counter. Why it is asynchronous mod 4 counter? Simply the different clock pulses are applying, right? Different clock pulse, right? So here I am going to apply this separate clock pulse. Here I am going to apply separate clock pulse, like that. So I can call it as asynchronous. Or if I say this terminology, output of one clock signal drives to the clock of another flip-flop, right? So output of, if I take the green color, so output of this flip-flop 1, out of this flip-flop 1 is given drive to the input of input clock of another flip-flop 2. Flip-flop 2. I can call this is asynchronous counters. Asynchronous counters, and they are going to count from 0 to 3. I can call it as mod 4 counter. Mod 4 counter, right? So for your understandability, I will try to redraw once again the structure. If I take one kind of anything, if I try to take the T flip-flop only, I am going to apply some kind of negative edge trigger, and this is also kind of T flip-flop, and this input will be connected for 1, yes, fine. If I would like to say this is asynchronous counter, see, it can be a up counter or it can be down counter. That depends on the way you are trying to apply the signals. Okay, fine. So for time being, I am trying to say that this is asynchronous counter. Why means the clock signal for this one, clock signal for the flip-flop 2 is going to get, which is depend on, or the output produced by the flip-flop 1. I can call it as asynchronous counter. Whereas coming to synchronous counter, it is going to be flip-flop 1 and T input and one kind of clock signal I have given. It is going to be a flip-flop 2 and it is going to get some T input from external side, and this will be the value 1. Yes. Now for this also to work something, it has to get some kind of clock signal. But here, as I am trying to say that they are synchronous counters. For all kind of flip-flops are going to be activated at once, right? All flip-flops are going to respond for the same clock signal. Same clock signals. Then we can call this as synchronous counter sum. Right? Means here in asynchronous counters, all flip-flops are not going to be clocked at the same instance of time. Whereas coming to synchronous counters, all the clocks are going to be, all the flip-flops are going to be clocked at the same instance of time. Right? So which one is easier? If I say the asynchronous construction of the counters is easier compared to synchronous construction of the constructor sum. Counters. Then in terms of speed, see, if I say in terms of design aspect, which one is very easy? This is easy. This is somewhat difficult compared to asynchronous counters, right? If I say in terms of speed, which one is going to be take time, which one is going to be take very less time, or which one is fast and which one is slow? Definitely I can say that with our relation I can say that this is slow, this will be the fast. Why? This is slow because one flip-flop, for example, if I say that second flip-flop is depend on the first flip-flop, am I right? meaning that after the execution of first flip-flop only, this output has to be given to the input of this one. So it is going to be definitely so. Whereas coming to here, no, all are going to be executed at the same time parallelly. So that's the reason it is going to be fast. It's going fast, right? These are some of the differences between the asynchronous counters as well as synchronous counters, right? So in the next class, we'll try to see some kind of examples for various kind of counters. I hope I understood clearly. Thank you.